Hi everyone. Here I am with my students for discussing the topic on dynamic CMOS design. Here my students named Hema Bharati, Kaushik, Kevin, Mridula and Elena are here for discussing about this topic. So they are in preparation mode. Here my students are going to start the discussion based on the topic.
Hello everyone, today we are discussing about dynamic CMOS logic design. Dynamic CMOS design is a method of implementing digital ICs which work on clock control signals. This act on two phases, namely pre-charge phase and evolution phase. It is used for faster operation and low power consumption than static CMOS design.
So next I am going to explain about the operation phase in dynamic CMOS design. So there are two primary operation phase in dynamic CMOS design. One is pre-charge phase and next is evolution phase. In pre-charge phase, during the pre-charge phase, the output is charged to the high voltage using the pre-charge transistor, that is nothing but a PMOS. In evolution phase, during the evolution phase, depending upon the input, the pre-charge node is remains high or discharged to low using an NMOS.
Advantages and challenges of dynamic CMOS. And advantages: reduced transistor count. Dynamic CMOS typically uses fewer transistors compared to static CMOS, which results in which leads to reduce the complexity of the circuits. Next, speed in the circuits. Dynamic CMOS circuits, fewer the transistor and parasitic capacitors, which allows the faster switching speed. It's typically used in high speed applications like digital signal processing and microprocessors. It reduces the area. It is an area efficient device. Dynamic CMOS typically acquires very less area compared to static CMOS. Challenges: charge leakage. In dynamic CMOS, the charge stored in the capacitor can leak over time, leads to loss of logic states. Power consumption in dynamic CMOS, because of less transistors, it acquires more amount of energy because of charging and discharging of transistors. And noise sensitivity. Dynamic CMOS prone to noise because it can be corrupted by external disturbance.
Here the applications of dynamic CMOS design. Dynamic CMOS design is often used in areas where high speed is crucial and low power consumption can be managed. They are high speed processor, digital signal processor, complex arithmetic circuits, large scale integrated circuits. And then the examples of dynamic CMOS design. The logic gates families are domino logic. It can rectify issues like charge leakage, and then NP domino logic, complementary output using both NMOS and PMOS transistor.
I'm going to conclude the session. Dynamic CMOS is a powerful technology in VLSI. It offers speed and area. Some of the disadvantages include based on the applications like power leakage and noise sensitivity. In the advancement in technology such as scaling and clock techniques, continue to mitigate these challenges and allowing the dynamic CMOS to remain relevant in high-speed computing applications. Thank you.
Okay, as discussed by our students, even though dynamic CMOS design is far better than static CMOS design in terms of transistor count, and faster calculation. So there are some complexity issues in this dynamic CMOS design. So if that complexity issues also overcome from this technique, then it will be very much a needed approach in all VLSI circuit design. Thank you. We can see in the next video.